In this module, let's talk about deploying database updates along with your code. This doesn't involve deploying to Azure App Service, but most applications typically involve some sort of backend database. The database is a dependency for your code, but it's a separate environment from your web hosting. So you need to keep the two environments in sync. You wouldn't want to deploy code that relies on a new database column or table and not have that column or table available in the database. Your code would throw an exception. So let's talk about ways that you can deploy database updates. The traditional way is to generate a SQL script of the changes to your database. Then you could run that script yourself on the database. Or you may need to provide the script to a database administrator because maybe as a developer, you don't have access to make changes to the production database. That's still a tried and true method of deployment because it allows the database administrator to review the changes and make any optimizations to the SQL and make sure that the changes don't affect database performance or cause a loss of data. It also provides an opportunity to back up the database before any major changes. The only challenge is timing, making sure the database changes are deployed by the time the code needs them. You might require a deployment window when the application isn't available. And you might also want to structure your database changes so the current version of the code still functions. When you introduce a change that could break the existing code deployment, like removing a column from a database table, that's called a breaking change. So again, timing your updates is critical. With DevOps processes nowadays, we often want to move fast with continuous integration and deployment in order to deliver value for clients, and that includes updates to the database schema. You might be familiar with Entity Framework Code First, which is a feature of .NET that allows you to define your database structure based on the classes in your application. Entity Framework is an object relational mapper. It has tools that allow you to run commands to update the database based on changes in the object classes in your code. During development, you can include code that will drop the database and recreate it based on changes to the data model. Of course, you wouldn't want to do that in production. So Entity Framework Core has something called migrations. These will create a set of commands in code to update the database with changes. You run a command on the command line or in PowerShell to create a new migration when you have enough changes to your data model that you want to apply to the database. That creates a class with those changes. You can then run a command to update the database with the changes, and they get applied to the database. And a table in the database will be updated to capture the ID of the migration, so Entity Framework Core can keep track of the changes and not apply them more than once. You can also include code in your program.cs file to automatically apply any outstanding migrations on application startup, which is a convenience during development, but you should never include this in your released code to update a production environment. The reason is that the update code could get called multiple times in a server farm environment. Multiple users could access the application on different servers at the same time because of load balancing, which would call the update multiple times. That could leave the database in an inconsistent state. And remember, Azure App Service has the scale-out feature. You might configure autoscale and not even know that your app service is running multiple instances. So if you want to use Entity Framework Core Code First migrations to deploy changes to your database in shared environments, like production or even staging and testing, the recommended ways from Microsoft are to either generate SQL scripts and use those during deployment, or to run the migrations from a controlled environment. Let's talk about each of these. Code First migrations lets you generate code describing the updates. But it also includes commands that will generate the SQL equivalent of the migration. So again, you could review the changes and apply them directly to the production database. Or you could include the script as part of an automated deployment process, which is basically the second option, running the command in a controlled environment. That could mean manually running the commands to update the database by remoting into the database server. Or more often, it means deploying the updates during a continuous deployment process. You can include a step in your GitHub Actions workflow or Azure DevOps pipeline that generates a SQL script based on the migrations defined in the code, and then have another step that deploys the script and updates the database. We'll be looking at this code later in the demo. These code and database updates will be taking place from a single location during a single process, the deployment workflow, and that addresses the risk of multiple updates taking place at once. In addition to SQL scripts and Entity Framework Core code-first migrations, there are other options for deploying database changes. If you're using SQL Server, you can manage your database structure using a data tier application, or DAC. This is a SQL database project in Visual Studio or Visual Studio Code that defines all the SQL Server objects, like the tables, views, logins, and stored procedures. You can also reverse engineer an existing database into a DAC project. Once your database is defined in the project, it can be compiled into a DAC package locally or in a DevOps pipeline. That generates a file with the extension DACpack, which is actually a zip file containing the database definition, and it can be run on SQL Server to create or modify database objects, to revert to a previous definition of the database, or to provision a new database. Deploying changes using DACpack files gives you the ability to identify and validate changes before you actually run them. So it's a powerful process. In the upcoming demo, I'm going to show you how to deploy Entity Framework code-first migrations from your GitHub Actions workflow to update an Azure SQL database. That's done using a GitHub action provided by Microsoft. That action takes a SQL script as an input, but it can also take a DACpack file as input. So whether you choose code-first migrations or the data tier application approach, you can deploy your changes using the same continuous deployment process. And yet another way to deploy changes to your database is using Azure Resource Manager templates and scripts. That's really getting into infrastructure as code, so we won't go into that in this course. But you may want to look closer at that as part of your DevOps process. In the rest of this module, I'm going to show you some updates to the sample application that includes a backend database to read and modify expense records. Then we'll create an Azure SQL database in the cloud, which is a platform as a service offering where Microsoft will host the SQL Server for you, and you just deploy your database structure and data. Next, you'll learn how to deploy database updates using the Publish feature in Visual Studio. Then we'll talk about how your ASP.NET Core applications can authenticate to Azure SQL Database. We'll configure the app service to use something called a managed identity, which is like a service account for the app service. Next, you'll see how to configure a GitHub Actions workflow to deploy database changes along with the code by using Entity Framework Core code-first migrations. And finally, we'll modify the deployment to include an approval step after the code is compiled and the SQL script is generated, but before the changes get deployed. So let's start by looking at the updated sample application next. I've updated the sample application to store some data in a database. You can get the code from the course downloads. It's pretty standard Entity Framework Core code first. Let's go through it here. First, I had to add some package references in order to get the Entity Framework Core functionality. You can get those by managing the NuGet packages for the project. All I added were the Entity Framework Core and Entity Framework Core.SQL Server packages. That automatically included the other dependencies. Next, I added some entities. There's just expense and expense type. Expense just stores basic information, like the ID of the record, information about the expense, and a reference to the expense type entity, which is a foreign key in the database. Expense type is just lookup data. Next is the DB context that makes these entities work with Entity Framework. So each entity is a DB set, which will translate into being a table in the database. We'll come back to this seed data class. Everything gets wired up in program.cs. The Web Application Builder class has a services collection, and we use addDBContext to add that to the services collection so we can use the DB context with dependency injection. The connection string passed to use SQL Server is coming from the appsettings.json file. So we're using the SQL Server local DB that gets installed with Visual Studio. And the name of the database that will get created is right here. We'll be overriding this value when we deploy to App Service, so we can use Azure SQL Database in the cloud. Back in program.cs, a little farther down is where we can do things like use ensure created, which will drop the database and recreate it if there are any changes to the schema. Of course, you don't want to include that in your released code. You could also call context.database.migrate to apply migrations automatically, But again, this isn't good practice in production, for reasons that we discussed earlier. But this is also where you can seed the database with any lookup values and test data, which is why we have this call here. Let's take a look at this class. I put it in the project context file, but it is its own class. The initialize method just checks if there's data in the expense types table. And if not, it creates some lookup values. Farther down is some code to create a few expenses as test data. To visualize and manipulate the data, I used the scaffolding feature of Visual Studio to create the pages. On the index page, it just lists the expenses in the database. And that comes from the code behind, where the dbContext class is passed in through dependency injection. And it's used to get all the expense records from the database. Now let's look at the SQL Server on this VM. We can do that by going to View and opening SQL Server Object Explorer. I'll expand this server and look at the databases. There aren't any yet, and that's because I haven't created the migrations for these entities. The connection string in appsettings.json says that the database will be on this SQL Server instance and will have this name. Let's set up migrations now. You can do that by using the .NET command line interface or using PowerShell. I've already installed the Entity Framework Core tools, so let's open up the Package Manager console. If you don't have the tools installed, you can run install-package Microsoft Entity Framework Core.tools. I've already done that, so let's create our first migration by using add migration, then the name we want to give this migration. I'll call it initial create. It'll take a second, and this file gets created, which tells Entity Framework how to create the tables in SQL Server. It's added to the migrations folder in your project. This describes the tables, and each time you run add migration, it creates a file like this with just the changes to the data model since the last migration. Now you can also generate a SQL script with these same changes. Just call script-migration. And that generates SQL that you can then review and run on the database. This gives you an extra level of confidence that you understand exactly what's going to happen in the database. And it also allows for a division of responsibilities, where you can give the script to the database administrators to run in production, for example. Now, if we want to run this migration locally on this machine, we can do that by calling update-database. That'll use the connection string in the appsettings.json file to connect to SQL Server and run any outstanding migrations. If the database doesn't exist, this will create it. If it does exist, there's a migrations table in that database that Entity Framework Core will check and only apply migrations that haven't been applied before. Let's go back to SQL Server Object Explorer and refresh the list of databases. Now there's a database with the same name that was in the connection string. If I expand this and expand the tables, there are two entities and the EF migration history table used by Entity Framework Core Code First migrations. Let's look at the data in the expense types table. There isn't any data yet, and that's because the seed data method gets called when the application first starts up. Let's run the app locally here to create that data. I'll start debugging the app. And the first thing it will do in the program.cs is call the seed data class initialize method that you saw earlier. So it'll take a few seconds the first time when there's no data present, and it'll create that data. Now if I go to the expenses tab, there are 3 records in the expenses table, and the expense type name is coming from the expense types table via the foreign key on the expense record. Let's edit one of these. The expense type dropdown list has the lookup data that was created by the initialize method of the seed class. I can change this value and save the record. If I go back to Visual Studio, I still have the query window open from the SQL Server Object Explorer, and this is for the data in the expense types table. Let's refresh this. So there's the lookup data that was inserted. Now we have a working application that manages data in a local SQL database. Let's create a database in Azure that we can deploy to when we deploy the application code.